Hi, I'm Ridhi Kashyap, and I'm an Associate Professor of Social Demography at the University of Oxford. In my research, I'm very interested in questions about human development and population inequalities, and especially gender inequalities. I'm also very interested in how the digital revolution is transforming our lives and societies, as well as creating new kinds of data streams that are relevant for social science research. In my lecture today, I'll talk a bit about this. I'll talk about how the digital revolution is creating new kinds of data, digital trace data, and talk about how social scientists can use this to ask interesting social science questions. Hello, so I'm very excited to talk to you today about digital trace data for social research. So I'm a demographer, so a lot of the examples that I'll talk about today draw on my own interests, which is gender inequalities, health and mortality, migration, the kinds of topics that demographers such as myself study. But I think general thrust of my talk today will be to emphasize that there are many interesting and creative ways in which we can use digital trace data for social science research questions. And I'll start off first by outlining what I see as sort of the features of digital trace data within a changing data ecosystem, as I think of it. Then I'll talk a bit about examples of digital trace data. There's a tendency to think that digital trace data is all about Twitter research, and it isn't, and that's part of my role today. There is also Twitter, and we'll hear more about that, but there's a wide range of digital trace data sources, and my goal is to sort of show the breadth of applications and the types of use that have already been published in the research literature and think a bit about extensions moving forward. I also then will think about and describe research strategies that you could use when using digital trace data. And then in the end, I'll emphasize broad principles, considerations that researchers should think about when using digital trace data. So I want to start off by talking about the digital revolution, because that is really why we're here today, right? It's this. The digital revolution is the staggering diffusion of the internet, mobile technologies, really digital technologies that have taken place. If we think about it, really in the last 25 or so years, that's a staggering technological transformation of a kind that has really revolutionized our lives, societies, economies. And here you see this is data from the International Telecommunications Union, the UN's ICT agency. And we see here just the staggering diffusion of mobile phones here in red. And then we see also the diffusion of fixed internet, as well as then in the mid-2000s, mobile internet connections. And we see this plateauing of landlines. This is global digital connectivity subscriptions per capita measures. But I also want to show you here that this is a digital revolution that is a global revolution. So we see this trajectory of diffusion that is pervasive across different regions of the world. There is no region that is left behind when it comes to the level of the takeoff of mobile technologies in particular, but also internet technologies. And I think that's important to bear in mind when we think about computational social science as a field, right? There's a tendency to think that the computational social science is, because of the existing literature, largely about the global north, when actually this figure tells us that it has a lot of potential also to speak to urgent, important topics in the context of the global south, because it is really a digital revolution as a global revolution. Another thing I want to highlight, which is linked to also some of my own research interests, is if we look at some parts of the world, for example, Africa or Asia, you don't see any of the blue bars, right? You just see red bars, which means that mobile technologies have really been the first large-scale telecommunication infrastructure in these settings, which means that this is a really radical technological transformation that is a first of its kind, and thus its social impacts are also likely to be quite significant in these settings. So this digital revolution is first and foremost a social transformation. Technologies are permeating different domains of our lives and really have transformed social, economic, political life. And I think COVID has really shown that, taken that to a whole new level. Digital technologies really made life possible in a way that was perhaps never possible before, because we could connect with each other, we could continue doing work, we could access goods and services. So in some sense, this amplification of the salience of technologies, the social transformation of the digital revolution has really been underscored during the pandemic across the world. But this social transformation also is connected with the second implication of the digital revolution, in that it's a data revolution. The fact that our lives are digitalized, the fact that digital technologies permeate different domains of our lives, means intrinsically that data are generated by our use of these technologies. And so this digitalization of our life creates data byproducts, which are essentially digital trace data. And that's going to be the topic of my lecture today. So we think about digital trace data within what I call a changing data ecosystem. We can think of digital trace data as emerging from two processes. So first and foremost, social life is digitally mediated because we're adopting new technologies, digital technologies and platforms such as social media. And our adoption of these platforms is creating new data streams. A lot of these data streams, obviously, are being stored because the companies that are owners of these data have incentives for storing them, right? They generate business from these data streams. They're intrinsic to their business models. So, for example, social media companies want to collect information on demographic or behavioral attributes of their users because they repurpose that and sell that to potential advertisers. That's an example of digital trace data that I will talk about in this lecture as well. So essentially, this is the first data generating process for digital trace data, is that social life is digitally mediated, which creates itself data streams that are stored. But the very digitalization of information, digitalization of data itself, has resulted in the storage of different types of information about what is essentially offline life, also in digital forms. So examples of this would be consumer transactions, video recordings of streets. All of this is digitally stored, which means this information can be processed and used as data from which social phenomena can be observed and described. So if we think about these two data generating processes of digital trace data, we can think of some common features across digital trace data. The first common characteristic of both these streams of digital trace data are that at its core, all of these data were not intentionally collected for research in the same way that a survey is collected for research. A survey is a curated instrument designed by a researcher with a specific theoretical goal, a research question in mind, and of course the respondents to a survey give informed consent. They are agreeing to participate in the research because there are sort of established protocols when we do survey research on how and what the expectations and norms about that are. On the other hand, with digital trace data, because these data inherently are not collected for research, they are data that require some degree of repurposing. And that has interesting implications, both from the usability dimension. Often that means that these data might be messy or unstructured, but it also has implications from the user, from the perspective of the human subjects that are being analyzed, because effectively they haven't really given informed consent to this research. And the ethical implications of that are really important to bear in mind when using these data. Some researchers have argued that because this bedrock principle of informed consent doesn't apply to digital trace data, higher standards of ethical scrutiny should apply to them. We need to think about broader contexts of what were user expectations when those data were generated, about how they would be used, also in our consideration when evaluating their applicability for social research contexts. The second feature of digital trace data that is interesting from a research perspective is that they're non-reactive. They provide opportunities to observe without asking. That also allows for a type of dynamic measurement. Again, this connects with that. This has ethical implications too. Essentially, you're observing without asking. You're not really obeying a kind of standard protocol of informed consent that is, as I said, the bedrock of survey research. There are often measures of behavior and activity that digital trace data are capturing. So this is because they are byproducts of the digitalization of life. And it's interesting to contrast that with sort of self-reported measures when we think about the domains of application for digital trace data. As I'll talk about later on in my lecture, there are a number of examples that show the value of digital trace data for studying topics where there might be inherently social desirability biases in the context of studying specific phenomena, such as abortion. But on the other hand, if that is the case, we also then need to think a bit about, well, if this is non-reactive and we are studying behaviors rather than self-reported measures, right, what are sort of the ethical implications of that in our research designs? I should note here first and foremost that I'm talking about digital trace data in a sort of general common features way, but digital trace data really do come in so many different forms that it's very hard to talk about one rule applying to everything. And I think they come in different forms, both practically. Digital trace data can constitute text, images, counts of users. They can be of different forms. They can come in different outputs. But they also come in very different forms in terms of the kinds of features and the kinds of limitations that they have. And so this is really just meant to be a sort of a general introduction to thinking about digital trace data. Specific use cases will, of course, require specific kinds of considerations. So just to emphasize the different types of digital trace data examples that have already been used in the research literature within computational social science, I'm going to provide in the next few slides some uses of different types. So to start off with, a lot of, unsurprisingly, I'm going to look at social media sites. So sort of here's a really nice example from my perspective, this paper by David Garcia and Bernard Remay. They look at collective emotions and social resilience in the aftermath of a terrorist attack, and they're looking at tweets. They essentially see this kind of with pretty detailed temporal resolution, how right after a terrorist attack, especially the 10 days after a terrorist attack, you see sort of a rise in negative emotion, which is first anxiety, then sadness, and surprisingly, actually, the least amount of negative emotion is anger. So essentially, this is sort of text analysis applied to Twitter data to look at large-scale social dynamics, collective sentiment with high temporal resolution done using Twitter. This is an example from my own work where, using data from Facebook's marketing API, we collect data on counts of Facebook users by gender, and then construct the Facebook gender gap index, a female-to-male ratio of Facebook activity, which we find is highly predictive of internet access gender gaps that have been computed using survey data. And because of this high correlation, we train models that allow us to nowcast, to predict current levels of internet and mobile access gender gaps across the world. So this is on our website, digitalgendergaps.org. We've built this infrastructure where we essentially are nowcasting digital connectivity gender gaps. This is a global sustainable development goal indicator for where there's actually a significant data gap in conventional data sources. But here, digital trace data are providing us the temporal as well as geographical resolution to provide real-time estimates of an important social indicator. Next set of examples I want to provide are from web search queries, perhaps the earliest examples of the application of digital trace data, and perhaps the most well-known one is Google Flu. And here, Google Flu essentially was a public health surveillance system that was set up within Google to see if aggregated search queries could help us track influenza over the flu cycle. So essentially, nowcasting again, the idea that we can predict using aggregate search queries, flu seasons, ahead of official CDC statistics. And Google Flu, when it first started off in 2008, actually did really well, right? It started off very promisingly, and this was one of the reasons. I mean, this paper by Ginsberg and colleagues, published in Nature, really sort of heralded in some ways the beginning of this digital revolution and its implications for monitoring, studying social dynamics. The fact that we could really, ahead of official statistics, know what the flu season was going to be like was really an exciting thing for public health researchers, for epidemiologists interested in disease surveillance. More recent examples from COVID show that aggregated search queries can also be used to predict the incidence of domestic violence, intimate partner violence. And this is a paper here by Coxell and colleagues, recently published in the European Journal of Population. And they find that actually the predictive power of Google search queries is stronger. The title here, the caption is wrong. It should not be abortion rate, it should be intimate partner violence. And in Italy, the predictive power of Google search and intimate partner violence is much stronger during periods of crises. So in the sort of lockdown period and post-lockdown period in Italy, the fact that there was Google search indicators for the number, the hotline number, really nicely correlated with the actual calls to the number, administrative data to the calls made to this number 1511, which is the domestic violence helpline in Italy. And they use this to emphasize that there is tremendous potential here in specific contexts. So here they emphasize that's the lockdown sort of crisis context for using search queries for monitoring, again, hard to capture phenomena. Another example is provided by research looking at blogs and internet forums, and this is research by Monmunda Chaudhry and Shushavan Day, and they look at Reddit, and they look at essentially social support provided on mental health forums, again through text analysis applied to forum data from the Reddit API. Another example that has been used a lot, particularly in applications in the global south, has been mobile phone data and call detail records from mobile phone data. And this is a very well-known paper by Blumenstock and colleagues that shows essentially that call detail records, essentially networks of who is calling who, and intensity of calling, is a really good predictor of poverty and wealth at fine levels of geographical resolution, and can really augment the existing survey data either by filling gaps in specific regions, but also by providing higher temporal resolution. So the demographic and health surveys, which they use as the ground truth when training their model, are of course a large-scale survey infrastructure that costs a lot of money, also takes a lot of fieldwork time. In contrast, the passively generated call traces, the call detail records, can map and help us predict with reasonable accuracy the same and recreate this map of poverty in the case here of Rwanda. Another example is sensor-based data. And so in this paper, we see the application of using electricity smart meters to look at and create different types of typologies of household types and composition. So again, this is driven by a desire to supplement resource-intensive methods, such as censuses and large-scale surveys, and consider whether just behavioral data that are generated through digital technologies can essentially make those data pipelines more cost-efficient in the long run. And so in this paper by Newing and colleagues, they look at how electricity smart meter consumption profiles look very different for different kinds of household compositions. And of course, one of the key roles of censuses is to, of course, enumerate the population, but also to understand differences in household structures and compositions. And looking at smart meters, we can actually look at, again, with high temporal resolution, the different household compositions have very different peaks in when their electricity consumption is. Also, we see households with children, for example, experiencing peaks in certain types of the day that we don't see in households without children, and so on. So essentially, we can infer demographic characteristics about households by looking at electricity smart meter consumption. And an example here from the US is provided by the work by Gebru and colleagues, which looks at a car census as observed from Google Street View, right? So what they do is they create a census of cars by looking at images of Google Street View that have about 22 million automobiles from across the US. And they find that, of course, features of cars, as well as sort of characteristics about cars within specific geographical areas, are highly correlated with demographic makeups of neighborhoods. And using this relationship, they're able to sort of predict with a high level of accuracy the socioeconomic makeup of US neighborhoods. And again, their argument is very similar to the paper by Newing and colleagues. They're essentially trying to explore to what extent are these different types of digital trace data sources providing us the resolution that can help complement and even augment conventional sources like here the American Community Survey or the census. So that's a range of examples of the different types of digital trace data that exist. Now, in the next part of this talk, I want to give or discuss research designs using digital trace data. And I like to think of research designs using digital trace data as essentially broken down into two broad categories of designs. So the first type of work on digital trace data thinks about the ways in which we can use these data as a lens for, a new kind of lens for social measurement, and think about the ways in which the features and the promises of digital trace data can help us do a different kind of social science research or improve social science research. The second type of research using digital trace data is really interested in understanding digitalized lives and the implications of digitalization. So here the idea is that digital trace data are themselves crucial for making sense of the digitalized world, of our use of digital platforms and spaces, of social dynamics in the online world, and also for thinking about the wider social impacts of digitalization, which of course is, given this rapid technological transformation that has happened in roughly 2.5 decades, is surely worthy of social science research. So let's start off by discussing this first type of research design that we commonly see applied in studies that rely on digital trace data. So a number of the examples that I've already shown were trying to do some kind of nowcasting or forecasting. The idea of nowcasting is simply that because of the higher temporal resolution provided by digital trace data, they offer the ability to predict the present or say something about the immediate future in a way that conventional data sources that have slower time lags, that are much more resource intensive, such as a survey or a census type source, digital trace data can help fill some of those gaps and provide higher frequency measurement. And this is often useful, or the value of this is articulated often in relation to specific contexts where there might be significant data gaps. So let me give you a couple of examples. In the demographic literature, one of the things that is often noted is that of the three demographic processes, mortality, fertility, and migration, migration is the demographic process, the demographic dynamic that's the hardest to measure. That's often because population registers or census-type sources don't really capture mobility, or they capture mobility over very long time scales. So we don't actually know when people move across international borders or even within internal national borders. So mobility or migration is the hardest of the three demographic processes to measure. And working from that, a lot of social demographic research has been very excited about the possibility of using digital trace data for studying migration. So in one of the earliest examples of this, in this paper here by Zagani and colleagues, they looked at whether information on the number of expats as determined by Facebook, how that related with actual estimates of immigrants who had moved abroad in official statistics through databases such as the World Bank's here. And they found that they were actually highly correlated. So those who were deemed to be immigrants or expats based on Facebook's aggregated estimates that they provide through Facebook's marketing API were actually highly correlated with the World Bank estimates. And for them, this was suggestive of the idea that Facebook's digital census was a useful source for potentially filling this data gap on measuring migration. In a similar extension, and with a more refined modeling framework than that first paper, my colleague Francesco Rampazzo and colleagues, they look at how we could potentially predict migration using Facebook in combination with labor force surveys, as well as other administrative data in the context of the UK. So measuring migration is a big challenge in the UK because we don't have a complete population register that countries like Sweden or Denmark do. And registration of residence isn't compulsory. So effectively, we don't really have any exhaustive population level statistics on international migration, as well as even internal migration. And Rampazzo and colleagues make the argument that through an integrated data fusion of labor force surveys, as well as administrative data, along with data from Facebook retrieved from Facebook's marketing API, which gives counts of users that Facebook infers to be living abroad, they can combine these in a sort of fusion approach to provide estimates of migrant stocks and changes in migrant stocks in the context of the UK. And then in this paper, they also try and evaluate the impact of Brexit when Britain left the European Union to see if that has effects on EU migrant stocks in the UK. Another example, again, to come back to digitalgendergaps.org, in this, here we see, this is survey data that's available from the International Telecommunications Union for different parts of the world. So we did a sort of exhaustive search as a part of the project on what are the best available surveys that we can find that let us, across different countries, measure digital connectivity by gender. And we actually found that there were significant data gaps in this, in being able to measure this indicator, because a lot of Africa, as well as South Asia, just didn't have a very recently available survey to be able to estimate this measure. An interesting thing to note is that, originally, the reason why I started doing this work was because I was interested in studying the social and demographic impacts of digital technologies. But very soon I realized that it was actually very hard for me to even study the impacts of the digital revolution because the data to study its impacts was lacking. And that's where I started turning to digital trace data to see if that could be integrated within research designs to explore also the impacts of digitalization. And so here, as I said, what we're trying to do is we're now casting, and on the website we provide monthly updated estimates of internet and mobile access gender gaps across the world, using at its back end the Facebook marketing API's counts on female and male Facebook users across different countries. And so when we look at this map, we see that across South Asia, but also Sub-Saharan Africa, particularly West Africa, we see significant gender gaps disfavoring women in access to the internet, and we see also mobile phone gender gaps in the same area, in the same countries. So this nowcasting style of research is perhaps, I would say, the first or the most sort of widely known cases of the application of digital trace data. And the general strategy with nowcasting research designs is that there's some kind of phenomena or social indicator that researchers are interested to measure, where there is some kind of a data gap or there's a temporal lag in being able to measure that. And the nowcasting idea is that we use the higher frequency measure generally coming from a digital trace data source, integrate that to predict the outcome that we're interested in. Now, this kind of design, of course, requires us to have some ground truth measure that we trust, that usually comes from some kind of high-quality survey or potentially a census or another measure where essentially we have the ground truth, but the ground truth is either not available across all parts of all the geographies that we might be interested in, or there's a temporal lag such that we want to fill that by training a model where the digital trace data indicator is sort of doing the bulk of the work. Now, there are a few considerations that I think are relevant when doing nowcasting with digital trace data. And I think the Google flu example, again, is useful to come back to because it provides us a cautionary tale about how nowcasting can go wrong. So as I said, when the first paper heralding really the exciting promise of Google flu back in 2008 was published, right, Google flu was doing really well. It was doing really well at predicting influenza prevalence, and it was showing that search queries, when aggregated, are actually picking up of traces of behavior that are meaningful social signals. Sometime in 2012, however, Google started significantly over-predicting flu prevalence. It started over-predicting flu prevalence, and it just never sort of seemed to be able to come down to actual predicted CDC levels. So we see the orange bar here, or the orange curve, is nearly double that of the official CDC estimate for flu prevalence. Now, why did that happen? The reason that happened is Google's algorithm changed. So essentially, when people were starting to search for flu, Google's algorithm would recommend to them, even if they didn't have the flu, that they might be interested in flu-like products, or medicines to cure the flu, or just essentially the recommendation algorithm started essentially encouraging people to search for the flu, such that these changes implemented in the algorithm affected the behavior of users on the platform, such that search volumes increased for the flu significantly, right? So this is a sort of classic case in this literature of algorithmic bias, where algorithms distort the behaviors such that we can't distinguish. We're confounding whether the thing that we're observing is actually driven by the algorithm or by behaviors of users. And I think algorithmic bias, of course, the Google flu example provides a cautionary tale. It tells us that, that it in some sense humbles the big data hubris that was abundant at that time. But it also tells us that we have to think really carefully about how we operationalize the measure, right? Another criticism of the Google flu project was that perhaps it just had too many different predictors that were not even related, or too many different queries that were not even related necessarily to the outcome of interest, influenza, such that it was really just a correlation-seeking exercise that was not theoretically driven. So one thing we might want to do in a nowcasting exercise is think hard about, right, that we want to keep our measures perhaps confined and theoretically driven to the outcome that we actually want to predict, such that there's a sort of a link between the predictor and the measure that we are interested in, or the phenomenon that we're interested in. The other thing we should consider is that algorithmic bias isn't just that algorithms confound behaviors or confound measurement because we can't distinguish algorithmic changes from changes in actual behavior. Another problem with algorithms is that algorithms can often discriminate against specific groups, or they can discriminate against marginalized populations, and that may be because training data are biased, or because the algorithms themselves are black box, and the data generating and modeling process is not transparent with them. So there are a range of different ways in which bias affects nowcasting examples, but not just nowcasting examples. Examples across the use of digital trace data have to carefully consider the role of algorithmic bias and the distortions that algorithmic bias introduce into any research incorporating digital trace data. Another key issue to consider when thinking about digital trace data use, and again, that provides a cautionary tale in terms of their application, is this issue of population drift. And the idea that social media platforms, for example, change all the time, right? So as a demographer, I like joking that that Facebook is now an aged or an aging platform. So you really see global demographic trends of aging on Facebook through the population pyramid of Facebook that is much, much older than, say, Instagram or TikTok, right? And that's the kind of population drift in that there is a change in the user composition, but also in the ways in which people use platforms that changes over time, which creates, of course, its own unique challenges of how do we make sense of what it is that we're measuring. So what might be a good signal in one point in time and might work effectively for nowcasting in one point in time might not work effectively for nowcasting at another point in time. And actually, a lot of nowcasting studies find this, including in some of our own work in digital gender gaps. We find that model predictability, or the same model, model performance can weaken over time, and the likely reasons for that is population drift. Similarly, in a lot of the literature on mapping poverty using mobile phone data, they're very good at mapping spatial heterogeneity in capturing spatial variation, but they have a much harder time in predicting changes or trends in poverty over time. And a large part of that is probably due to population drift. With technological diffusion processes, the users of technologies change, and as a result, these correlations that are, of course, guiding the nowcasting approach aren't as effective anymore. So some general takeaways when doing nowcasting with digital trace data is that we should think of digital trace data as complements, not as substitutes, right? So, for example, in the work that we've done with digitalgendergaps.org, but also in some of the research on migration that I talked about, they find that integrating across multiple sources, where combining digital trace data as a predictor along with other measures that come from, for example, survey data, can be useful. Combining different kinds of data sources in our prediction model helps us guard against some of these risks of population drift or changes that are observed due to algorithmic confounding. Another thing to consider is that, of course, as I said, people are spread across multiple platforms, users are spread across, they use different devices, they use different platforms, which means that if we can integrate measures from different platforms, for example, a social media study within our research designs, we are making our research designs more robust, that we know not just that the phenomena that we're observing may be more generalizable, but we're also guarding ourselves better against issues such as population drift. A second application of digital trace data in terms of research designs or research strategies is to analyze the impact of events and shocks in real time. Now, this is, of course, due to the fact that digital trace data are non-reactive, they're passively generated, they're byproducts of the use of digital technologies. And an example here, again, that comes from the study of migration in this paper by Flores in the American Journal of Sociology that looks at a law change here in Arizona. This was an anti-immigration law called SB 1070 that was implemented in the state of Arizona. And Flores then tracks sentiment to different immigrant groups in the aftermath of this law, right? And what this study finds is this very sort of sharp difference in that we see increases in the number of tweets about immigration as well as negative sentiment to specific immigrant groups, but not universally to all immigrant groups, that takes place in Arizona, but no similar changes in tweet volume takes place in the neighboring state of Nevada, where this law is not passed. So a key consideration when doing this kind of analysis, where we're using digital trace data to analyze the impact of some kind of a specific shock or an event, is to think a bit about, well, what's the appropriate counterfactual trend, right? So in this study here, we see the counterfactual, this is a difference in difference design, where the counterfactual trend is the trend on Twitter and public sentiment to immigration in Nevada, and then observing changes in Arizona at the same time. So that's kind of the counterfactual. This is the expected trend in the untreated group versus the treated group, right? So that's a sort of classic design when trying to analyze the impact of a specific event, is to identify what is a good control group for doing this analysis. In contrast to nowcasting type studies, where there's often a ground truth measure that researchers are trying to model or predict, there is no ground truth here, right? There is no ground truth here. What researchers are often interested in is analyzing differences, relative changes in response to some kind of an event, such that there is one group that gets treated and one group that is untreated from that shock, and then trying to sort of look at pre and post that event, how the trends look. A third type of design, again, leveraging the novel measurement properties of digital trace data, is work that tries to use digital trace data for measuring tricky, hard to capture human behaviors. So from my perspective, a very nice example of this is provided by the literature on online dating in the social demographic scholarship. So demographers, such as myself, have been very interested in marriage and family patterns for a very long time, but we've actually never really observed in our work mate search heuristics. We don't actually know how dating markets operate. We only infer behaviors and mechanisms by looking at aggregate outcomes like marriage rates, or who marries whom, or who partners with whom, but we don't actually know very much about what preferences and dating strategies and how do actually dating markets operate, right? We know very little about that, or we had known very little about that until digitalization and the advent of online dating platforms. Of course, in places like the US now, online dating has really replaced traditional venues of meeting, like through families and friends or through community institutions, such that this really provides a kind of new lens for social measurement of a kind of behavior that previously we were never able to measure. So in this paper here by Brook and Newman, they look at what they call the desirability rank by looking at messaging strategies, or they're looking at messaging behaviors on a large online dating platform. And essentially, they look at who messages whom, and then they compute a desirability score based on who receives more messages from more desirable others. And so it's a kind of page rank type measure of desirability. And what this measure is giving us is essentially, and then they look at demographic differentials in this desirability score across 4 cities, and they find actually that the patterns are very consistent across cities. And perhaps this is unsurprising, because of course, what's unsurprising here is that women become progressively less desirable as they age, with peak desirability when they're 18. And men, on the other hand, seem to become more desirable with peak desirability when they're 50. Right? So this is something that perhaps we would have learned from romance novels, but maybe we definitely had never observed before at scale. And we see it here in this study. And we also see very interesting differences by ethnicity and by education. Again, things that we probably would have learned through hearsay, that men become more attractive as they are more educated, whereas for women it's a bit of a U-shape. An undergraduate degree is just enough. So this is something that is quite, again, something that we wouldn't have really known about had we not had behavioral traces from online platforms to be able to analyze this process. So again, mate search heuristics, something that the demographers have been very interested in because they want to understand why is it that aggregate level marriage rates and marriage patterns are the way they are? Why is it that we see these kind of consistent patterns of homophily, right? Why is it that similar others match? But we don't understand the mechanisms for it. And these kinds of data could help us unravel some of these mechanisms. So not only are they useful for understanding new behaviors, they're also, or understanding old behaviors in new ways, but they're also very helpful for theory testing and also for potentially theory generation. So in my next two examples, I want to talk about how a lot of the emphasis or the emphasis in these research designs, where the focus is more on understanding digitalized lives and the implications of digitalization, rather than purely just thinking about digital trace data as a lens, a new kind of lens for social measurement. So in the first example of thinking about digitalized lives and social dynamics in digital spaces, which digital trace data can help us do, in some of the work that I've done with also 6 participants, and this conversation started while we were in 6 2017, we used Facebook's marketing API to look at sexuality disclosure by demographic characteristics on social media by looking specifically on Facebook. So Facebook, again, through its marketing API, provides counts of users, essentially aggregate counts based on different characteristics that you can see on profiles. And of course, one of the key indicators or a key measure on a Facebook profile is, of course, your own gender, but also who you're interested in, right? And the general interpretation of being interested in someone, at least that's what the qualitative literature shows, is that it's used as a kind of sign of signaling someone's sexuality. And what we found was very interesting differences by age and by gender in the US on Facebook. So we interpret these data, or we interpret these patterns as providing us very interesting measures of disclosure of social signaling at scale, right? In a way that is much harder to do in a kind of survey-based research design. So we found the proportion of US Facebook users disclosing any sexuality was obviously peaked in the sort of mid-20s or early 30s, but we found this very interesting difference where we have more women saying that they're interested in men and women than men, right? So we have many more women who have bisexual interests than men with bisexual interests, whereas we have many more men who have explicitly heterosexual interests than is the case for women, right? And so we see these kind of interesting differences in sexuality disclosure on Facebook, and we also then further dig in to trying to see how do these patterns look also by marital status. And we find, for example, that amongst younger cohorts, sexuality disclosure doesn't go down amongst married individuals, whereas for older cohorts, marital status kind of substitutes for sexuality disclosure. Being married is enough information that is provided that sexuality isn't, whereas for younger cohorts, those in their 20s and 30s, we find that even if they are married, they're still equally likely to say that whether they have bisexual or same-sex interests. So a second example, and this is more an example of a kind of work that tries to look at the implications of digitalization for social processes or social outcomes, is on social media gender gaps and their implications for economic gender gaps. So in this paper by Garcia and colleagues, they use the same data that we use in digitalgendergaps.org, again, data from Facebook's marketing API, where they look at the Facebook gender gap, and they look at if the Facebook gender gap observed with some lag in the year before can help predict the gender gap in economic outcomes. This is from data at the country level from the Global Gender Gap report. And they find that net of a range of other controls, the Facebook gender gap is able to predict economic gender gaps such that places where Facebook gender gaps are smaller, the economic gender gap shows is also smaller, and it shows sort of progress towards gender parity, closing gender economic gaps to the advantage of improving circumstances for women. So this is an example where in a research design, they take data from social media, aggregated data, create an indicator from it, and then they use that and connect that with data from another source, which is the Global Gender Gap report. And then through combining these two different data sources, they ask the question, does social media also affect other offline social processes here linked to economic opportunity? So that's to summarize the different kinds of research designs and strategies that are possible with digital trace data. The last few minutes, I just want to talk a bit about broader considerations when using digital trace data as researchers. So as I've shown that there's really different ways in which you can use digital trace data within your research questions and to answer different kinds of research questions across different across different social science fields. But I think that's really a good starting point for a key consideration when using digital trace data is, what is your research question, right? What is your research question, and how can digital trace data actually help you address it? There is obviously an abundance of different kinds of data sources available, and there's lots of exciting things that one can do with the digitalization and the data revolution that has ensued from it. But just because there is a lot more data and a lot of it is exciting and big doesn't mean we should use it. We might want to take a step back, and before we start thinking about how to use digital trace data, we really want to make sure we have a very specific question in mind where there is a real clear rationale for why digital trace data can help us do something that we might not be able to do otherwise. And I think I like using that test a lot because it helps me think a bit about what's the appropriate data for the question, rather than saying that the data is exciting, so let's do the research, right? Let's start from the research question and then find the right data for it, and be creative about thinking about the different kinds of data that can be useful for answering a question. Ultimately, no data are perfect, and that's true also of survey data. That's also true of large-scale population data. Just no data are perfect, but every data set has its unique strengths in relation to a specific question, as well as its weaknesses. And I think that reflection should start very early on in the research pipeline, that we need to have a research question, and then we need to think about what are the appropriate data sources that would be useful to answering that question. When using digital trace data, as I said, we have to think really hard about, is it possible to use this data in an ethical manner? Just because there is a lot of data and it's accessible doesn't mean, again, that we should use it. And as I said earlier in my talk, a lot of researchers have made the argument that because digital trace data don't exist or are not generated through protocols of informed consent, that higher standards of scrutiny should apply to them. Then we may want to ask, are the data accessible, right? Are these things that we can even use and can we access in some way? And there might be APIs, or there might be specific cases where we might need to use and create relationships with the providers of the data, which might be companies or other kinds of organizations. So, of course, accessibility is a key underlying concern when thinking about research pipelines and research strategies with digital trace data. A really important issue, again, when using any kind of digital trace data is, what are you trying to do? and what is your theoretical framework, and what is your measurement strategy. And we see this as a recurring question in different types of research designs, right? So for example, in a lot of the nowcasting examples, a big question has been, what's an appropriate measure? How do we operationalize the concept that we're interested in such that we have a stable variable, a robust predictor of the outcome that we're interested in a way that doesn't result in overfitting or doesn't result in this correlation breaking down over time. So this is a really important question ultimately about measurement. Another important question is, what's the theory framework, the theoretical framework that's guiding this research? Are we trying to test a theory, or are we going to go and try and generate new theoretical insights by analyzing social dynamics? A lot of the papers that I presented here, for example, the paper by Garcia and Remé that looked at social dynamics in the aftermath of the Paris terrorist attacks, I mean, it's very theoretically motivated, their argument. They have a very clear theory guiding their research about the different types of sentiment and emotional change and the processes of social resilience that they would expect based on Durkheimian theories about collective effervescence. So there's a sort of theoretical rationale that's guiding the use of their data, and from a publication perspective, that can actually help strengthen your ability to publish this work, is if it's really guided by key theoretical perspectives that are relevant in your field. Another important consideration is one of generalizability and the wider implications of your findings. And this is, again, very relevant to consider when thinking about questions such as those where you're looking at the impact of specific events on the context, on, for example, public attitudes or sentiments. Who are we really capturing in this, right? If we're doing a Twitter study and we're trying to analyze how does something change in response to a particular event, well, okay, who are we capturing on Twitter, right? Who does this finding speak to? Who are we excluding when we're not measuring, when we're using a digital trace data source? Sometimes the fact that some groups are missing in a data source is itself an interesting observation, as our work on gender gaps show. So until we started building these maps and creating gender gap indicators, the knowledge about these significant gender disparities in internet and mobile access in many parts of the world was something that was not really properly known and discussed in the literature, and trying to understand this process of mapping inequalities can sometimes benefit from understanding who is missing, right? But that's, again, a question that is linked to what you're trying to do. But if your question is one about trying to understand the impacts of a particular phenomenon, then if some groups are more likely to be missing in your research when you're using a digital trace data source, that's important for you to consider in evaluating the generalizability of your findings. One way that you can address this is by thinking about, again, can you compare or validate your measures against other sources of data, right? So that could be other sources of data, other sources of quantitative data, but also could be other sources of qualitative data. Are there researchers that have done work, or could you do that work that could help you understand, for example, whether the phenomenon that you're observing on digital traces does actually reflect behaviors of interest. So for example, in the work that Connor and I did in trying to understand and measure sexuality disclosure at scale on social media, we used a lot of qualitative work to inform our understanding of how individuals were using social media in different ways to make sense of our findings. For example, the gender differences or the age differences that we found. And we also used a lot of qualitative research to understand how specific users use profile fields to make sense of our findings. So qualitative research can also help inform and make sense of the things that we discover using digital trace data. So that's all that I have for this lecture today. Thanks. So in this lecture, we've seen how social scientists have used digital trace data in different ways as well as the ways in which digital trace data can be used in different kinds of research designs and research strategies. These data offer unique opportunities but also have their own unique challenges. Ultimately, no data is perfect, and we have to remember that when we design our research. Good research requires clear, well-formulated research questions, clear theoretical and measurement frameworks, as well as a thorough ethical consideration of the implications of our research. I encourage you to think about ways in which you can incorporate digital trace data to address questions that are of interest to you.